Hello, everybody. While we're waiting to see what happens with the book request, I'm going to talk about Wireshark. This is a piece of software you'll be using throughout the semester. Wireshark is a free download. Here's one site that is supposed to help you download it. If you don't want to copy that down, you can just go to Google and say Wireshark download. What Wireshark is a program that is used in industry to get the actual bytes that are going across the network. But not just the bytes. It organizes it in readable form so we can look at the protocols that our messages are using and make sure they're doing what they should do. It is used. I had a student once in this class who, after the class, went to work at an internship, I think it was, and they discovered he knew Wireshark, and they put him to work on it. So it's possible that you might see it. Now, I have Wireshark downloaded, so I'm going to bring up Wireshark, and I'm going to start it off. I have to tell it first, what do I want to look at? Well, Ethernet is the best answer. This happens to be Ethernet 5, it's version 5, but any Ethernet, whatever Ethernet you have is what you want to look at, the best, highest one you got. Once I set that up, that means that's the way, what it's going to look for. It's going to look for all the messages going back and forth that are being carried on Ethernet. So I'm going to say I always get that wrong. Capture start. And now you see the three windows of Wireshark. The window that lots of things are happening in, the yellow window, is keeping track of the items that are going back and forth between from the nodes that are on my LAN or to those nodes. We'll be looking at those in a minute, but I want to generate something I can look at. So I'm going to click over here, and I'm going to pick, the University of Cairo. Just to have something to use. I'm getting some information from it. You can see the faculty and institutes, Faculty of Engineering. It's a little slow, but not bad, considering it's coming a long distance. I'll try a different one. Well, I think I've had it, so I'm going to stop it. I'm going to go backwards. I'm going to go backwards again. And now I'm one more to go back, the live wire again. I've got what I want, so I'm going to go over here and I'm going to stop it. The red stops it. Now we can look at what we have. This file can be saved, by the way. We have in the left hand area here, we have a packet number. At least 14,000 packets have gone back and forth in 117 seconds. This is time in seconds. This is the IP address of the node that is sending out a packet. This is where it's sending it to. This is the protocol it's using in that packet, and this is some extra information about it.
You can analyze any part of this. What I'm going to do is I want to look at one of the early applications. So there's a funny little line you can just barely see here. Let me make sure. It says apply a display filter. I'm going to do TCP. Now those are all the TCPs that went back and forth. I need to know what my IP is. So I'm going to go to the command prompt. I would type that in the search and do IP config. If I do that, it will come up with my Ethernet address for Ethernet 5. Remember, we had Ethernet 5. And it's a real long one because it's an IPv6, which is gigantic. It starts with 2600:8805. That should be enough for us to find it. So let's look. Here it is, 2600:8805. So let's click on that. And this is the same as this middle box here. So you can either do it here or in the box. It doesn't matter which. There's something, this part is the words for us, the English, something we can understand. This down here is for the computer. Those are the bytes in hexadecimal. I'm going to start by expanding the transition control protocol, the TCP. The TCP is a level, a layer of the Internet model. If you remember, for the TCP IP model, we had the application, so the user, and then we had the transport layer, which was TCP. Or I should say one of the choices is TCP. Now, a TCP is coming from a particular port on my machine and going to a particular port on a different machine. Its stream index is going to be 0. Will probably be that'll be useful, I think, in a while. Its segment length is 1. And if you keep going down here, I gotta get this out of the way so I can move it some. You'll see the TCP payload, which isn't much at this point. It's 1 byte. You'll see flags, and if you'll notice, one of the flags is 1. Now, where are all these? How do you find them in here? Well, you have to know what the TCP form is. And I happen to have that right here. And I don't have it right here. I thought I had it right there. I did a minute ago, but I guess I don't. So I'll go over here and I'll type TCP. And I'll bring it up from Wikipedia. Now, this is a header. This is the header that the TCP portion, TCP protocol, puts on what the application gives it to send across. The application sends a payload, and this is what goes on top of that payload. If you'll notice, there are 2 bytes here that represent the source port, 2 bytes here, a sequence number, a acknowledgement number. We're going to get to talk about those in a while. The flags that I mentioned here, and the actual payload is down below here. Notice source port and destination port. We go back to where I was. The source port is those 2 bytes. No, pardon me. Yes, those 2 bytes. The destination port is those 2 bytes. And you could look them up as, turn them out of hexadecimal into integer, and you into base 10, and you get 443. Now you notice I don't have any euros here. I get, or IP addresses. I only have ports. The IP addresses will come later. In here, this is the first of my TCP messages that I had here. If you look, when we go back to here, that was at the beginning. You'll notice that it says it's an ACK with sequence number 1. That's important. What that means is that I'm beginning a session. If you look back here under TCP, we are doing what is called a 3-way handshake. I send a sync, the place I'm going to sends a sync ACK, and then I send an ACK. We do that to get ourselves established, to get ourselves ready to send messages back and forth. Now, I don't see here's 2607F, so let's look at this one. It's sending me an acknowledgement. It didn't send the sync. I thought it would, but that's okay. It may not be the right one, but let's just look around here anyway. The messages are going back and forth. We'll look at those in more detail later. And what I'm interested in is that you'll notice that there are sequence numbers and ACK numbers. Everything I send across the internet has a number attached to it, the sequence. When the receiver gets the packet, it checks the sequence number. If it's not the next sequence number it expected, something is wrong. Perhaps it has to wait because the packets are coming out of order. It also puts a sequence number on. But what it does when it sends it back to me is it gives me an acknowledgement of the last sequence number it received, plus its own sequence number. If that acknowledgement number is not what I expected it to be, then I may have to retransmit the bytes that didn't get there. So we each have a sequence number, and we each acknowledge that sequence number to the other side of the conversation. That's how we go back and forth in what we're doing. You can see some of the sequence numbers are getting kind of high here. Yeah, that's one of mine. So let's see what we get here. I have that there. Sequence ACK analysis. This is an ACK to the segment in frame 1219. It took a round trip time of 0.001 seconds. that go back and forth. So this is the first application we will probably look at, the TCP. Probably it won't be the application. It's the base of everything we need so that we can look at what's going on here. I said that the TCP puts a heading on what it gets, the payload it's supposed to send across. Well, the TCP doesn't send it across. All the TCP has is the source port and the destination port, and the information it wants to carry over. It does not know what the IPs are. That is the job of the Internet Protocol. So the TCP information, including its heading and the payload, is sent to the next lowest layer, the Internet layer, or networking layer. The networking layer, that's where we worry about the source address and the destination address. This is also the part of the system that determines how it's going to get from me to wherever I want to go. It has to find a route. That's part of its job, to determine how to go from one place to another. Now, that's not the end of the story. It has the route, but it's not going to send out the bits. That's the job of the lower two layers. But in our system, the lower two layers are sort of gathered together in Ethernet. So this is where we have the data link layer and the physical layer that are going to send things across. They're going to take care of the bits that go out there. If you'll notice here, the frame had 74 bytes, tells me how many bits that were, and it tells me how it did, rival time, all kinds of little things about the time. That is one of the things we will look at. Now, I think I have time to look at one more. I hope I can get to it without everything going wrong. DNS. This is another protocol. I'm going to try this right here. And I'm going to close off the frame. I don't want it open anymore. I don't want the Ethernet open. I don't want the Internet open. There's no TCP, but there's a UDP. This is an alternative for transport. The TCP is a good worker. It tries to make sure everything goes right. It keeps trying. UDP is a lazy worker. It makes an attempt, but it promises you nothing. I think most people call it a quick and dirty way of sending things across. But some of the higher level routines use it. They don't think they need the other part. And the domain name system is part of that. The domain name system is very important to the Internet. The domain name system keeps track of the IPs for all the domains that you might name. So, for example, when I put down the University of Cairo, my machine probably had no idea what the IP was of that. So it sent a DNS to a domain name server. It sent a request and it said, would you please look this up for me? And the query I sent over was, I want www.bing.com. That's what I want to know. And this machine tells me that if I want to see the response, go to 723. So let's look at 723. Again, I don't need that. Now, here's the answer. $723 is this unusual routine. There's some other pieces of it. Here's a euro or two of it, an IP. There's the IPs down at the bottom here. That's how addresses are found. It's more complicated than it looks because it might have to actually use recursion because of the way the domain name servers are set up. But that's one of the applications we're going to look at. So my plan is that probably within the next few days, I'm going to send you a homework involving your getting Wireshark up and trying some things. And then I hope to make a video talking about some of the applications, DNS, HTTP, email, some of the upper level applications. That's as far as I'm going to go right now. See you later.